it will remove only one CH3 group. The second CH3 will not be removed. Okay, there is a reason for that. I don't want to explain that. Now the reason is, let me tell you. C, H, 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 C, I, I. Okay. Now this is these hydrogens. These hydrogens are very easily replaced. Once these are replaced, this will drag the electrons here, and these will drag the electrons onto this side, and therefore these electrons are dragged more here. These electrons are dragged more here, and replacement of this, that is, it is getting replaced by heterolytic bond fission. This will become more difficult. Substitution of this hydrogen with this I will become more difficult. That's why this only one CI3 is getting removed. Now, in the next step, once this is formed, this will react with NaOH. This will react with NaOH. And this H will be given to this. Okay. Or we can say, how will you? We can put like this. See, OH will attack here, and this will be removed. I will use that. I'll write the mechanism. Let me remove all this stuff. OH attacks here on this carbon, and this bond, it forms a carbanion. It forms, it forms a very stable carbanion. Look here. Stable in the sense, the carbanions will be stable when one of the questions, the electrons are removed from this carbon. See, in the exam, I asked you a question about how carbanions are stabilized this also is very slow, are stabilized by presence of NO2 or CN group. Remember, NO2 and CN groups are electron withdrawing. So if you have a carbanion which is bonded with an NO2 group, then this is minus. These electrons can delocalize into this, and it can form 3 bonds here. Oh, no, not 3 bonds, 2 bonds. Yeah. So you have C double bond N, O minus and O minus with plus. This is how carbanion is stabilized by the presence of an NO2 group. Okay, this is how a carbanion is stabilized by a presence of NO2 group. Right? You can show this with the double bond also here. So double bond will be stabilizing. NO2 CN group also will be stabilizing in the same fashion. See here. I don't know how many of you have got this answer. I'll ask you to look into the video. Lone pair of electron, carbanion. Now see, it can resonate, and the negative charge here can be delocalized onto the nitrogen. Double bond C, double bond N, 2 lone pairs here. It can be delocalized. Okay, so this is how. So very similarly, this I will stabilize this anion. Okay, and what is left behind here? CH3. See here, CH3, C, double bond O, OH. Okay, now see here you have a carbanion which is strong base. It's a very strong base compared to, it's a base, and here is an acid. So this base will abstract this proton. An acid-base reaction will occur, right? It will abstract this proton and will form. I'll wipe this out. This you don't require. This I just given the explanation. If I write it here, this is what I had taken already. Now, one second. Yeah. Now, this will abstract and see what happens. It forms Ci3H plus CH3 C double bond O, O minus. What is the counter ion? We have used sodium hydroxide. So it forms sodium acetate. Water soluble.
Screen കാണല്ലേ sir?
ഓ പോയോ?
Sir, 9:45 വേറെ ക്ലാസ് ഉണ്ട്.
Okay, now then stop here. We'll continue tomorrow. Okay, bye.